Good afternoon. This is the final report for VP3B for analysis of complex structure, semester 2 of 2025. Student name is Behruz John with code S4003953, and course coordinator is Dr. Shrikant. Got a table of contents here. We begin by introduction. So the VP task or video project task is consists of 3 assignments that go for throughout the whole semester. VP task 1 involved students going into the real world and choosing 3 structures that they found to be interesting. That needed to be a truss, a frame, and a spanning beam. Students who were lucky enough could find the whole assignment in just one picture, but yeah. VP task 2 involved students for solving for indeterminacy of a frame and a beam using the force method and a slope deflection method. The content for such methods was delivered in class through lectures, tutorials, pre-recorded lectures, also the workshops. And finally, VP task 3 again involved 2 problems which students have to solve for indeterminacy of structures using the moment distribution method and also the approximation method. We look back at VP task 1. As I mentioned earlier, I had to find 3 structures, so this would be my truss, Hallam Valley Trail or steel, and I assume de Young's modulus of 200 GPa. Spanning beam seen over here with 3 different legs to be classified as a spanning beam. This was in my house in Narre Warren South. Assumed property of a 10 GPa for timber. Dimensions given over here below. Similarly, the simple frame over here, very similar characteristics. And the only calculation for that one was moment of inertia, which I calculated for my simple frame. Very simple equations that are used to get the moment of inertia. Now we're going to VP task 2, where students were given unique questions. W and P was linked to your student number, which mine being S4003953, the last 3 digits divided by 10, 95.3. The lengths and height were, from what I believe, were unique to every different student to avoid plagiarism and whatnot. And so we begin the analysis of the simple frame, trying to solve using the force method. Force method involves us making a redundant force. For my one, given that there is 2, 4, and only 3 equations, there's 1 degree of indeterminacy. Removing AX was the simplest option. All of that done. After that, removing this AX onto SkySieve, I got very similar results: 370, 370, 91, 91, 95, and 95, all less than 10% error. And then we begin analysis, cutting the sections into 5 different cuts, finding the big M. That's important for the final equation, finding the internal moment and shear. Although shear was not important, the moment was the most important one. I did it for some of them, but left it for the other ones. And then after that, you do the virtual frame where AX comes back in with no other external loads, and you solving for the other reactions. And so, yeah, now you solve for smaller m. For all 5 different cuts, M2 is equal to M3 because there's no change in this section at all, so it's the same pretty much. And so it comes to the final equation of solving for delta AX. All of this is done over here, and then so from there, horizontal displacement, finding all of that gave the AX to be 83.16, a very similar result to SkySieve. Less than 10% error in them. Some of them might have been greater than 10, but less than 15, which was really great. And yeah, that was that. And then solving for the final shear force and bending moment diagram through the equations. This is the shear force diagram compared to SkySieve, very similar results and values. Likewise with the bending moment diagram. Now I want to go to slope deflection method. Once again, W and P are unique to students. 95.3 for my one with length of 5.4. Over here I got the idealized structure to make it easier for analysis. And so, yep, we keep going. Although this one says pinned, we were encouraged to take it as a roller support with no horizontal forces, as there's no other external horizontal forces, so there's no need to calculate for any x forces. From here, calculating the fixed at any moments from the back of the textbook with the equations, solving for mn equations, and then applying joint equilibrium equations at MBA and MBC. All of that's done to get these values that come handy with the final equations. Also, MBC and MBA is equal to 0, which I believe is called point of inflection, if I'm not wrong. Don't quite remember that back of my head. And so after that, we calculate the reactions again from sections of A to B, B to C, and C to D. A to B and B to C. 5%, less than 15% error for CY, less than 5% error for AY, and less than 5% error for BY. And yeah, compared to SkySieve results, very, very similar. For the shear force and bending moment diagrams, likewise. And then we go on to VP task 3, which students had to find indeterminacy of this spanning beam using the slope deflection method. Moment distribution method, solving using moment distribution method. This was done on Excel. Certain formulas were used for finding this 99.5 value. Had to multiply 0.52 by the 192.5. That's done all the way. And at the end, you can see that the values are very, very close, and you can assume that they're balanced, depending on how many decimal points you took, but that's pretty balanced to me. And so from there, you do some cut sections on your section. Cut 3 was a bit challenging, going from left to right, so I decided to go from right to left, taking x coming from right to left. Made the calculation just a little bit more easier. And then after that, I drew the shear force diagram, and likewise with the bending moment diagram. And yeah, we go on to the final approximation method. Very simple, didn't take nearly as long as the other problems. With the 3 hinges at E, F, and G, solving for the internal forces at those hinge areas, calculating the horizontal and vertical reactions caused by the external load that's inside those hinges, and from there calculating the reactions at the fixed points of A and B, calculating the moments, and from there deriving the shear force and bending moment diagram. With SkySieve, on a free trial, it was not possible to get the bending moment and shear force diagrams, so I used another website that was online, and I managed to get very similar results in regards the shear. For the final one, did not manage to get the shear force and bending moment diagram. However, for this one, for the moment area distribution, compared it to another online calculator for beams, very similar results. And we go into the conclusion. As I've written down, it's been a great experience. Learned a lot, got to apply what I learned in class onto real world problems, situations, which was really fun. I would encourage this method of teaching to future students in analysis of complex structure, and also subjects that are somewhat similar to this, that involve structural analysis, encouraging students to go into the real world, obviously in a safe manner, but to explore things that they find interesting. And so yeah, I also want to thank Dr. Sri for his amazing effort in teaching his students. It's been a really pleasure being a pupil of Dr. Sri, and I hope that he's happy with the way students have been able to attempt his assignments this semester. And yeah, I hope my report is up to standards and I get good marks.